Okay, good morning to all of you. I welcomes to all in our lecture series on mathematical physics, that is your core paper 5 belongs to third semester BSc Physics on our syllabus. In our last class we have been discussed in detail about your solution to partial differential equations using separation of variable methods or variable separable method, whatever you can say. So if the differential equation contains independent and dependent variable where the function, suppose this is our differential equation, second order differential equation where u is the function of both xy, then this differential equation will be called as the partial differential equation. Likewise, this one is another partial differential equation where u is the function of xyz, here f is the function of xyz. These things already we have been discussed in detail, and how to solve a partial differential equation using separation of variable method. The steps are also we have been discussed in detail. We have been discussed and in that video I have been told that up to four steps, that then we can evaluate individual x and y, capital xx and yy. Up to this much I have been written, uh, but I suggest to all of you that you have to also add another point or step, then put x and y, whatever we have been evaluated in our step 4, that we have to substitute in the general or original solution whatever we have been defined initially. So this is our defined initial general solution, that is your uxy equal to capital X into capital Y. X here, capital X is the function of x, capital Y is a function of y only. So after evaluation of x and y, with the help of step 4, you have to put this x and y here. So another step, I suggest to you that another step you have to just write in your note. Okay, so here, and last class also we have been discussed a question by following the steps whatever we have been discussed, and this class we are going to be discuss, or we are going to be solve another few problems. Okay, so this is the second question, you can say. This is your second question that we have to solve by using separation of variable method. In short, I have been written SVM. Instead of writing separation of variable method, SVM I have been written here. Okay, so here the differential equation, partial differential equation is del u by del x equal to 2 into del u by del y plus u. So from this differential equation, whatever given in the question, one can be analyzed that here u is the function of both x and y. So here the solution starts that given differential equation is this one, and here it is clearly can be feasible that u is the function of x, both x and y. So using the separation variable method, that means we have to separate x and y. So here let the general solution is u, which is the function of x and y, will be written as capital X, which is the function of x, into capital Y, which is the function of y. These things your step 1, you can say. Then we have to differentiate this one with respect to x and with respect to y. Here del u by del x will be y will be constant, so y, which is the function of y, del x by del x, and del u by del y will be equal to x into del y by y. Let this is your equation number 2 and this is your 3. Now we have to substitute 2 and 3 in equation number 1. So here del u by del x is nothing but y into del x by del x. So here I written y into del x by del x. So here I not written again and again y is the function of y, so I omitted that one. Y is the function of y, but you have to keep in your mind that this capital Y is always a function of y, and this capital X is the always function of x. So y into del x by del x equal to 2, here 2 del y, del u by del y. So del u by del y is this one, so here I have been substituted, plus x into y, as it is u, so it will be x into y. Right, now we have to divide here you can we are following the steps. Okay, so after substituting these things, the step 3 is telling that we have to divide x into y with each term. Okay, so here we have 3 terms, this one, this one, and this one. So we have to divide x into y into z with each term. Here I mistakenly written z, but u is only the function of x. Okay, so here z is not there, only x into y. So now we have to divide x into y with each term. We get that 1 by x. Here if I will divide xy, x into y, then y got cancelled. It will be 1 by x del x by del x equal to 2 into 1 by y into del y by del y. So here if I will divide xy with this, it will be 1. So as this whole, that which is the function of x only, and this is the whole which is the function of y only, both are equal. So here we consider that both are equal to a constant k, suppose. Okay, what is our the so-called step number step number 4. Okay, so here then we evaluate individual solutions x and y by considering k, by considering a constant. Okay, so if you can if you want to add that one by considering a constant here in the step 4, you can write, no problem. So here so this 1 by x into del x by del x will be equal to k, and this value will be equal to k. So here del x by x equal to k into this is del x will be moved this side, and here this one you can see that 1 moved this side, it will be k minus 1 divided by 2. Here del capital Y by capital Y, and this del small y gone this side. Okay, so now we have to integrate this equation and this equation. What we are going to find out, see, del x by x integration equal to k integration of del x, and here integration both the side, right? So here del x by x means the integration will be ln x equal to kx plus ln c1. Let constant is your ln c1, the integrating constant. Okay, so ln c1. So here ln c1 moved this side, ln x minus ln c1 equal to kx. So it can be written as ln x by c1 equal to kx. X by c1 will be equal to e to the power kx. X will be equal to c1 into e to the power kx. And here likewise it will be ln y will be equal to k minus y by 2 is the constant, and integration of dy will be y, and plus ln c2 is another constant gone to this side. This will be ln y by c2 equal to k minus 1 by 2 into y. So hence y will be equal to c2 into e to the power k minus 1 by 2 into y. So we found x and we found y separately. Now according to step 5, we have to put this x and y in our original solution, whatever we have been initially defined, that is your uxy equal to capital X into capital Y. So separate solutions we have been found by using SVM. So hence uxy will be equal to c1 e to the power kx into c2 into e to the power k minus 1 by 2 into y. So here c1 into c2, let c into e to the power kx. This powers of exponential will be add up, so it will be kx plus ka minus 1 by 2 into y. Let this is equation number 4. In the question it has been given one condition that xy will be equal to 4 e to the minus 3x. That means at y equal to 0, the solution will be 4 e to the minus 3x. Now we have to put the y equal to 0. So here if I am going to put y equal to 0 in this last expression or last solution, that is your ux0 will be equal to this is given in our question. Okay, now we have to consider this equation, equation number 4, and substitute instead of y will be equal to 0. So here you can see that now equation number 4 will be, if we are going to be consider y equal to 0, so this will be, this term will be 0, and we are going to be find out u x0 equal to c into e to the kx only. So u x0 equal to c into e to the kx. Let this is your equation number 6. Now if we are going to be compare equation number 6 and equation number 5, this one, then we can found that c will be equal to 4. C will be equal to 4, and here you can see this is e to the minus 3x, this is e to the kx, so obviously k will be equal to minus 3. So general solution will be uxy equal to, instead of c we have to write 4 into e to the power, instead of k we have to write minus 3x plus here minus 3 plus minus 1 will be minus 4 by 2 equal to minus 2y. So e to the minus 3x minus 2y. So uxy will be equal to 4 into e to the minus 3x plus 2y. This is the solution of the differential equation, this one having the boundary condition, this one using SPM. So we have to move for the next question. Okay, here this is another question, question number 3, that solve this equation del square u by del x del t equal to e to the power minus t into cos x by SPM separation variable method. Given that u equal to 0 when t equal to 0 and del u by del t equal to 0 when x equal to 0. These two boundary conditions has been given, and we have to solve this one, and we have to follow the steps. Okay, the given equation in the question is this one. So from the question itself, it is clearly indicates that u is the function of x and t. So here the general solution, whatever we are going to consider, that will be u is the function of xt will be equal to x into t. Here x is purely function of only x, t is the function of only t. Now we have to find out the del u by del t. How much it will be? Del u by del t will be, here x will be constant into del t by del t. Okay, so again and again I am not writing the function of x, but keep in mind that this x is function of x. Okay, I am not writing again and again. Now we want del square u by del x into del t. So here del u by del t equal this much. Again we have to differentiate with respect to x, this one. How much we can get? That will be del by del x of del u by del t equal to del square u by del x into del t equal to del x by del t of this one. So here when it will be differentiate with respect to x, so this term will be act as a constant, right? So del x by del x into del t by del t, product formula we have to use. So first derivative of this one, this will be as usual we have to write, plus we have to keep as such x del by del x of del t by del t. As del t by del t or function of t is a constant for x, so it will be 0. Now we found del square u by del x del t equal to del x by del x into del t by del t. Let this is your equation number 2. Now we have to put this equation number 2 in equation number 1. We can found that del x by del x into del t by del t equal to e to the minus t cos x. It is very simple steps. The first steps or the steps whatever we are following, the 5 steps, it is always common for all the questions. So after 2 to 3 questions you will be automatically practiced upon that. Okay, so here e to the power minus t is moved towards left side. It will be e to the power t del t by del t is equal to cos x by del x by del x. As you can see, this term is function of only t, this is only x. So let this equal to a constant minus alpha square. See here I taken minus alpha square as a constant. You can consider any constants like k, c, p, whatever you can take, no problem. So here I consider that minus alpha square is your constant, that is this equal to this. So now we have to find out separately the solution of this differential equation and this differential equation. Okay, so here e to the power t into del t by del t equal to minus alpha square, and cos x by del x equal to minus alpha square. 4 equation, 5 equation we have been considered. Now we have to separately solve these 4 and 5 equations. So now from equation number 4 we can find e to the t into del t by del t equal to minus alpha square. Del t will be equal to minus alpha square into e to the minus t into dt. Now we have to integrate both the side. We can find that here integration it will be t, this integration will be e to the minus t, means it will be minus all will be plus, and alpha square e to the minus t, let constant is c1, let this is your equation number 6. Now from equation number 5, whatever we have, cos x by del x equal to minus alpha square. Cos x will be this much, cos x dx will be minus alpha square d capital X. Now we have to integrate both the side. We can find cos x integration will be sin x plus c, and this will be minus alpha square, and d capital X integration will be capital X. So capital X will be equal to minus 1 by alpha square sin x plus c. Okay. Here you just consider this one is your C2, okay, C2, and this will be C2, right? So x will be equal to minus 1 by alpha square sin x plus C2, let this is equal equation number 7. So next step is that the two solutions whatever we found t, that means equation number 6 and 7, we have to put in our general solution, that is your equation number 2, u equal to x and t. So instead of x we have to put this one, instead of t, capital T, we have to put this one, let this is your equation number 8. Okay, now here you can see this equation number 8 is going to go for the solve by using the boundary conditions. We have the boundary conditions at this one, u equal to 0 at t equal to 0, del u by del t equal to 0 at x equal to 0. Now we have to consider these two boundary conditions. Okay, now we have to apply the given boundary condition is this one. Hence the equation number 8 will be equal to, now we have to put 8t equal to 0, for t equal to 0, u equal to 0. So in the equation number 8, u will be 0, here t will be 0, t will be 0 means it will be e to the 0 will be 1. So we found that 0 equal to minus 1 by alpha square sin x plus c. So we found that 0 equal to minus, that implies 0 equal to minus 1 by alpha square sin x plus c2 into alpha square plus c1. Now here, to satisfy this equation, we can consider this will be equal to 0 and this will be equal to 0, right? So here we considered alpha square plus c1 equal to 0. But if we are going to consider this one equal to 0, then c2 will be sin x by alpha square. Okay, if I will be put this value in our original equation, then the original equation will be 0. Here if I will put c2 over here sin x by alpha square, then u will be 0. So only for that we have to consider this value will be equal to 0, hence c1 will be minus alpha square, and if we have to put c1 over here minus alpha square, the whole function is not to be 0, it is written dead. Okay, now we have to consider another boundary condition, that del u by del t will be equal to 0 at x equal to 0. First we have to consider del u by del t. So del u by del t here will be how much? By substituting this value of c1, that will be alpha square, here minus alpha square into e to the minus t. So if we have to consider del u by del t, then this will be the constant, and here the derivative of this one alpha square into e to the minus t with respect to t will be equal to minus alpha square into e to the power minus t, and derivative of alpha square will be equal to 0. So du by dt will be this term into this one. Okay, same thing it has been written, that del u by del t equal to this much, and according to boundary condition del u by del t will be 0 for x equal to 0. So the del u by del t will be equal to 0 here we have to put x equal to 0 means this term will be 0, c2 into alpha minus alpha square e to the power minus t. This could not be 0. This term could not be 0 because this is constant and this is exponential function having a particular t value. So hence to satisfy this equation c2 has to be 0. c2 will be 0. So here we found c1 equal to minus alpha square, c2 equal to 0. Now we have to put c1 and c2 in equation number 8. We are going to get the final solution. So u equal to uxt will be equal to minus 1 by alpha square into sin x here plus c2. That means 0 we have to put into alpha square into e to the minus t minus c1. c1 means will be alpha square. And plus c1 was there. Plus c1 means it will be minus alpha square, right? So here you can see if I will multiply again further simplification, if we are going to consider, we can find finally uxt will be equal to 1 minus e to the minus t into sin x. This is the final answer of this question. Okay, now we have to move for another question, that is your question number 4. Here you can see double derivative is there, or second order differential equation is there, and a first order also is there. So del square z by del x square minus 2 del z by del x plus del z by del y equal to 0. There is no boundary condition has been given over here. We have to solve by using SVM. So here given is this one. Let this is your equation number 1, and here clearly it can be identifiable that z is the function of x and y. Z is the function of xy, so we can use the variable separable method or separable variable method, and we are going to write the general solution of this given equation in the form of x into y. So here x is purely function of x and y is the purely function of y. So next we have to find out del z by del x, del z by del y, del square z by del x square. So here del z by del x will be this much, del square z by del x square equal to will be this much, that will be y into del square x by del x square. Let this is your equation number 3, and del z by del y will be equal to x into del y by del y equals equation number 4. So here I am explaining step by step, or you have to watch the video carefully and you have to write down the note accordingly. Okay, so put 3 and 4, these two equations we have to put over here, put over in equation number 1, and we are going to get y into del square x by del x square minus 2y into del x by del x plus x into del y by y del y equal to 0. Let this is equation number 5, and now we have to divide xy with each term. We can find here y is there, so it will be y by xy, this one del square x by del x square, and this term also divided with xy and xy, and we are going to get 1 by x del square x by del x square minus 2 by x del x by del x plus 1 by y, because x got cancelled, del y by del y equal to 0. So here we consider this del square x by del x as your x double dash, this is x dash, and this is our first derivative of y dash equal to 0. And here you can see that we just separated the x and y. Here you can see x double dash by x minus 2x dash by x. So x double dash minus 2x dash by x, and this term I taken right hand side will be minus y dash by y. So if both two functions which is belongs to x and y are equal separately, let this is also equal to k is a constant. Consider k. Okay, so here we are going to be separately solve this differential equation and this differential equation. That means x double dash minus 2x dash by x equal to k we have to solve. If we are going to solve it, this will be just you have to just further simplify that x double dash minus 2x dash minus kx, just k is going, x is multiplied with this k and taken to left hand side. Okay, so here this is the capital X, capital X. Let this is your equation number 7. Now the auxiliary equation of this equation number 7, again I written, okay, the previous page equation number 7, here I written the auxiliary equation of equation number 7 will be this will be m square, double derivative is there, m square minus 2m dash minus k equal to 0. Sorry, 2m only, 2m, m square. See, m is considered as dy by dx, that we have been studied in our first semester. So here double derivative is there, means m square, single derivative, so minus 2m minus k equal to 0. So here m will be 2 plus or minus root over of 4 plus 4k by 2, and the two solutions will be 1 plus root over 1 plus k, 1 minus root over of 1 plus k. So the general solution of this equation number 7 will be c1 into e to the power this root into x plus c2 into e to the power another root, that is 1 minus root over of 1 plus k into x. Let this is your equation number 8. Similarly, we have to solve the equation number 6, that minus 1 y dash by y equal to k, that is y dash minus ky equal to 0. Or you have to find out the auxiliary equation from here, or you can consider this in this format, that is your y dash means no, directly you have to consider this one, that y dash minus ky equal to 0. So this will be the for this one the auxiliary equation will be m minus k equal to 0. That means the root will be m equal to k. Or you can consider the logarithmic format, that is y dash can be written as del y by del y by del y, here 1 by y minus equal to k, and this can be written as del capital Y by Y equal to minus k del y, and then if you are going to integrate, and then this will be in the form of log, and finally you are going to get this solution, that will be y equal to c3 into e to the k y. Let this is equation number 3. Now using equation number 8 and 10, the general will be just we have to put this one is your x belongs to x, solution only belongs to x, and this is belongs to y. We have to just put these two solutions in our original solution, that this will be this much, x value is this much, and y value is this much, c3 e to the ky. So this is the answer of the given question. Now we have to move another question, that here it has been given question number 5, given that we have to solve this differential equation, that is 4 del u by del x plus del u by del y equal to 3y. Given condition is that u 0y equal to e to the minus 5y. Okay, so this is similar question, already we have been done this type of question previously, that 4 del u by del x del u by del y equal to 3y already given. The general solution will be x into y, u xy equal to x into y, because u is the function of x and y. So now del u by del x will be y into del x by del x, del u by del y equal to x into del y by del y. 4 and 3, this is 4 equations we have to substitute in our equation number 1, and we are going to get this one, 4 into y del x by del x plus x into del y by del y equal to 3 into xy. Now we have to divide xy, we can found, and this one 4 by x del x by del x, and here this term I am going to consider, going to take into right hand side. This will be my 3 minus 1 by y del y by del y. As this separately x and y both are equal, let this is equal to a constant, that is k. Okay, now we have to solve this differential equation, this differential equation separately, and we have to find the solution in the term of x and y, and we are going to substitute over this. Okay, so here 4 by x into del x by del x equal to k. So here 4 into del x by x, this del small x taken this side, and we have to integrate this one, and we can found that x equal to c1 into e to the kx by c. Okay, so here I not written once another step, that this ln c1 will be moved this side, it will be x by c1, see ln x minus ln c1, that means ln x by c1, and x by c1 will be equal to e to the power kx plus 4, and x will equal to kx by 4, x will be equal to c1 into e to the kx by 4. So here one step I not written. Similarly, we can solve this differential equation, that del y by del y, here 3 is taken this side, and minus if I will multiply it, this will be 3 minus k into del y, integrating we can get y equal to c2 into e to the 3 minus k into y. So u xy in general will be equal to this one into this one. So c1 e to the kx by 4 into c2 into e to the 3 minus k by k into y. So it will be c1 into c2 let c into e to the kx by 4 plus 3 minus k into y. Let this equation is 5. Now, as our given boundary condition or initial condition that x equal to 0, that this will be e to the power minus 5, this we are going to use in our equation number 5, and we are going to equate. Okay, so what we are going to do, but in question it is given that this will be equal to this one. So hence, if I am going to consider equation number 5, whatever previously page we have u x0, that means we have to consider y will be equal to 0, right? Sorry, mistakenly I have been written over here that this is 0, sorry, 0 y given, right? This is 0 y given, right? 0 y given, 0 y, that means we have to substitute instead of x equal to 0. So equation number 5 we have this much. So instead of x equal to 0, if I will substitute, then this will be u xy will be c into e to the power 3 minus k into y. Okay, so c into e to the 3 minus k into y will be equal to this much, the condition whatever given, the e to the minus 5 y. So here the coefficient of this exponent and this exponent will be c, here 1, so c will be equal to 1, and the power will be 3 minus k into y equal to minus 5y, hence k equal to 8. Now finally, instead of c1 we have to put 1, and instead of k we have to put 8 in equation number 5. General equation 5 will be equation number 5. Here c is going to be substituted as 1 and k will be substituted as 8. Then we are going to be found that 1 into e to the 8x by 4 plus 3 minus 8 into y. So uxy will be e to the power 4x minus 5y. Okay, so here we have to stop our today's class. In the next class we are going to discuss another question, that this one, using SVM find the solution of this one when x equal to 0, u equal to 0, and du by dx equal to 1 plus e to the 3y. Okay, and then we are going to discuss solution of Laplace equation in Cartesian coordinates. As you know that the Laplace equation is your three-dimensional Laplace equation in Cartesian coordinate system, that is your del square u by del square u equal to 0. That means del square u by del x square plus del square u by del y square del square u by del z square equal to 0. That means u is the function of x, y, z. We have to solve this equation in our next class. Next class we have to discuss this one. Before that we have to discuss this question. Okay, so thank you so much for watching this video. Watch carefully and write down the note accordingly. Thank you.